In Chapter 3, we'll be looking at inequalities and their graphs. An inequality compares numbers using less than, greater than, less than or equal to, or less than or equal to. I just said the same thing twice, so let's change that. It should say greater than or equal to. Now the symbols for this, we have x is less than 5, x is greater than 5, x is less than or equal to 5, and x is greater than or equal to 5. Notice that none of these say that is only equal to, and that's where we get an inequality, remembering that equalities would be equal to. One way we can remember how to read the signs is to remember that the sign will always be open to the larger number. So if we have 3 and we have a sign and we have 5, we know that 3 is greater than 5, which would not be true. So we would look at it again. We would say 3 is less than 5. Now that it's open to the 5, it's pointing to the larger number. Okay? Sometimes we like to think about animal that it makes. Some people say Pac-Man, some people say crocodile, some people say fish. I just make this monster, and the monster's really hungry. Monster would like to eat the larger number, so his mouth always opens to the larger number. If we're looking to translate equations, and we have the equation all real numbers p greater than or equal to 5, we would write this out. We have p for my all real numbers p, and then greater than or equal to 5, we're looking at having a sign that makes p greater than, so we have it as the bigger number, it's opened up to p, or equal to, making sure we have the equal sign there, and it says to 5. So we put in a 5. That's how we translate it. Now you can see p is greater than or equal to, it's opened up to the p, and 5 is your smaller number. Some people like to pretend that the beak of it points to the smaller number. Some people like to pretend the mouth of it opens to the larger number. Whatever works for you is okay. So try this example. Think about this sentence. The sum of t and 7 is less than -3. The first part of the equation we're looking at, changing my color, is the sum of t and 7. What does this mean? Just like in inequalities, we need to figure out what does sum mean. Sum means addition. And then we have t and 7 we're looking at. So addition of t and 7. So we say t plus 7. And then we're looking at is less than. Is less than means we're going to have a symbol that is going to go in this direction. This stuff is less than -3. So we put less than in, and then the last part we have is -3. And it's all by itself, so we just say -3. So now if we wanted to solve this equation and find out what value t can be, we look at this equation and say t plus 7 is less than or equal to -3. We treat this symbol here as an equal sign, and we come over to the 7 and we say -7 from both sides, just like we did with equalities. We -7 to the other side of the inequality. So -3 subtract 7 more gives me -10. So the solution to this one would be t is less than -10. If we want to check to see if we are correct, we can put -10 back into the equation and see what we get. So we have -10 plus 7 is going to give me -3. -3 is less than -3. Is that true? It is not true, but every number up into -3, when we're at the negative side, is going to work. So if I have -10.99999, and I put that in and add 7, we would get, let's try this. So we have -10.99, and when we add 7 to that, We have negative 3.99. So we know negative 3.99 is less than negative 3. So any number up until 10, if I wanted to do 10.0001, it would be the same case. So we say that t is less than negative 10 as our solution. Sometimes we want to check to see if a solution satisfies an equation. So I have the problem here, 2x plus 1 is greater than 3, and I have two values for x. I have x is equal to negative 3 and x is equal to negative 1. We're going to substitute this number in for x in the equation. So when I rewrite the equation, I say 2 times negative 3 plus 1 is greater than 3. Now I need to evaluate this side of the equation. 2 times negative 3 gives me negative 6. Negative 6 plus 1 is greater than 3. Now negative 6 plus 1 is negative 5. Is negative 5 greater than 3? If you notice, negative 5 is not greater than 3. It is a negative number. This is a positive number. We know it's not going to be equal. So we say that this is not a solution. Not a solution. Over here we say 2 times negative 1 plus 1 is greater than 3. So we substituted negative 1 into the equation up here. And we say 2 times negative 1, which gives me negative 2, plus 1 is greater than 3. Is negative 2 plus 1 gives me negative 1. Is negative 1 greater than 3? No. So again, this is not a solution. Let's try another example. Notice now I have 2x plus 1 is greater than negative 3 instead of 3. And I use the same values for x in this example. So if I substitute in negative 3 for x, we get 2 times negative 3 plus 1 is greater than negative 3. 2 times negative 3 gives me negative 6 plus 1 is greater than negative 3. Negative 6 plus 1 gives me negative 5. Negative 5 is greater than negative 3. Is this true? Not true? Not a solution. Now we try the other example. We're substituting in negative 1. 2 times negative 1 plus 1 is greater than negative 3. 2 times negative 1 gave me negative 2 plus 1 greater than negative 3. Negative 2 plus 1 gives me negative 1 is greater than negative 3. Is this a solution? Is negative 1 greater than negative 3? It is, so we have a solution. X equals negative 1 is a solution. Now we want to know, what does a graph of an inequality look like? Well, a graph of an inequality is going to be on a number line. So we draw our number line. I tend to like to have 0 somewhere near the middle, and I have the numbers increasing on the right side in the positive direction, and the numbers decreasing on the negative direction. If I'm looking at x is greater than 4, I'm going to graph on the number line where this would be. First, I need to say x is greater than 4. Well, I know I'm looking at the number 4, so I have the number 4 here. And for greater than, we're going to have an open circle that is not filled in at 4. Then I need to think, how would I make this work? What numbers could I put in for x? Could I put 3 in for x? Is 3 greater than 4? No, 3 is not greater than 4, so it's not going to be going in that direction. Is 5 greater than 4? Well, actually 5 is greater than 4, so I know it's going to be going in this direction. All the numbers going this way can satisfy the value of x. Any number that is greater than 4 will be in this direction. So I darken the line and I make my arrowhead solid to show that it's going to go on infinitely in that direction. Now let's talk about what type of symbols we're looking at. So for x is greater than some number, we'll say 5. We're going to have an open circle. We're also going to have an open circle. Open circle. When we have x is less than 5. We're going to have a closed circle, which is a dot that we're going to color in on the number line, like so, for when we have x is greater than or equal to 5, and when x is less than or equal to 5. The reason why we're using a closed circle is because the graph will include the number that it is equal to. When it's open circle, it goes up to that number very, very closely, but doesn't actually include that number, so that's why we need an open circle. So when we graph on a number line, I'm just going to put in a couple numbers here. I'm going to go with 2. We're going to go with negative 2. If I have x is greater than or equal to 2, I'm going to have a closed circle at 2. Make sure I color it in so I know it's closed. And then we're going to go greater than or equal to 2. Is 0 greater than or equal to 2? No, so I know it's going to go in this direction. I make my line darker, and I color in my arrowhead. If I'm looking at the equation, do it in green, x is less than negative 2, I'm going to have an open circle because it is less than, and it's going to go in the opposite direction because we know 0 is greater than negative 2. So any number in the opposite direction of 0 is going to be less than 2, like negative 3 and negative 4. I solid my line, I color in the arrowhead. Notice that I have an open circle at negative 2. The open circle at negative 2 is because it does not include the number 2. The number negative 2 is not included, so we have an open circle. In x is greater than or equal to 2, we know that 2 is included, so we have a closed circle. Let's try an example. So if we're looking at p is less than or equal to 6. We start off with our number line. And we put some points in. If I have negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Just want to make sure I have some numbers present here. You can skip count if you would like. I just went by ones on this one. So I'm looking at the number 6. Find the number 6 on the number line. We're here. Decide what type of circle should we have. Should it be closed or should it be open? Because I have the equal part here, I know I'm going to have a closed circle. So we make a closed circle at 6. Now, which direction should it go? It says P is less than or equal to 6. Notice 6 is open to, so 6 is greater than or equal to P. So when we're looking at this, we know 6 is going to be the bigger number. So is 5 less than or equal to 6? It is. So we're going to make our line going in this direction. Try hard to make it look nice and dark. And then we're going to fill in the arrowhead to show that it goes on infinitely. So in summary, we have the symbols here. X is less than or equal to 0, x is greater than or equal to 0, x is less than negative 2, and x is greater than 12. Notice I made my number lines to reflect what information I needed to graph. Instead of having to write out all of the numbers all the way up to 12, I just wrote out the numbers around 12 to make it simpler. So the first one when I graph, I'm going to have x is less than or equal to 0. So I'm going to have a closed circle at 0, and we're going to have less than, so it's going this way. Closed circle again because it's equal to. Next one I have x is greater than 0, equal to, so this way. This one here, x is less than negative 2, open circle, less than, and lastly x is greater than